Hello, this section is entitled Deploying a Container Application to Google Kubernetes Engine Using Pod. And that title's straight out of Google's docs, so I would say pods here, but that's an aside. So pods are a Kubernetes concept, first of all. And they build off of containers that we learned before. So it reminds you, containers themselves are like self-contained operating systems. They have their own OS, their own dependencies, and their own, your application that's running on them, right? And what pods are is the next higher up object where you can combine multiple containers together and have them run as a unit. And a couple things about pods is all those containers will share the same networking. They all have essentially the same IP address. So that's the first thing. So they're running on in a way that they all share same networking, and they also can access the same disks. So you can actually create disks that they're mounted in those that they all share. So in some way you could think of a pod as almost being its own concept of a kind of another machine, a host, right? That has these containers running in it that basically act as if they were on the same computer. They can talk using things like local host, right? So they could easily talk to each other, and they could also share files easy. Okay, so that's what a pod is. Now, in Kubernetes, there's a ton of other concepts, enough for a whole course. So for this video, though, or this whole series, we're just going to kind of end at pods and just kind of do stuff with pods, and then you can study Kubernetes separately. Okay, so the first thing you'll notice is that we're going to use our kube control command here, and that's how we're going to essentially create pods, and we're going to do it by using a file. So let's look at this file first. I have to get in the right directory apparently. Where's the full? Why aren't I seeing the file here? ls. Let me pause the video for a second. Okay, I'm back. Apparently I have my window stretched out. 3.2.2, I believe. Right, so cat, let me clear the screen, cat hello pod. So typically the way you create resources inside of a Kubernetes cluster is you write these declarative files, basically declaring what you want. And then Kubernetes will then take that declaration and actually do the operation of creating it. So in this case, you're describing what this pod should basically look like, right? And this top part is basically describing it's a pod. Metadata is things about the pod, in this case its name. And this is the guts of it here, right? Here you're specifying a container. Oh, by the way, this format of file is called YAML, if you didn't know that. It's a common format for sort of human readable text that's structured. So you've got containers, and then here, this is the container, just definition of a container. And this dash means you can have more than one of them. So if you had a dash down here, you can have a whole sequence of containers. Okay, the container has a name, it's just for friendly purposes, right? The main guts of it are these two lines. So here we're saying what container image to use. So we're using the open source Ubuntu of a certain version, right? And then, so that's basically the container image. And then within that container image, we're telling it what command to run. In this case, this is just a command called tail that just basically loops on, just keeps on looking at dev null, which is empty, and just keeps on looping on it. So essentially, what this does is it keeps this container from stopping, right? Because in this case, I want this pod to stay up, and I want all the containers just to keep on running forever. And that's what this is doing in this example. So the way we create this is we apply it. So kube control apply -f hello pod, and it will create the pod. So that's what this command is. So if you want to see what pods are running, you can do kube control get pods. And you can see here that you have one pod, name, right? Status, it's running, and it hasn't restarted, and how long it's been around. Now, one thing I'll look at here real quickly is this restarts. So another thing that pods do for you, in addition to just grouping containers, they also ensure that any containers that maybe die or get killed get automatically restarted. So what can happen is if that, I don't know, tail command somehow was to just fail for some reason and return an exit code of something, right? Or just the whole box just crashes for whatever reason, then the pod would detect that and restart that container, and then this restart count would start going up. And this one of one, by the way, this is basically, this says one container is ready out of one total. So we only have one container and it's ready. So thus that's the one of one. But if you had like 5 containers, you'd have 5 on the right side here. Okay, the next command we'll look at is describing the pod. So control describe pod hello. So there's a bunch of information here. So describing a pod basically gives you all the most popular or most commonly used information about the pod for troubleshooting it. And really important one at the bottom is that there are a list of events. So you can see what happened here, right? Just walk through this. Basically, when it first got created, it basically assigned the pod to a particular cluster. Not cluster, a particular node, right? Because pods actually are running on, or containers are really running on a particular node. So this pod or group of containers is running on a particular node, right? And you can see that it's basically the node needed to make sure that it had an image of Ubuntu there. I did this earlier, so it already had a copy of it. And then it creates the container, starts a container, and now the pod is basically up and running. Okay, there's a lot of features of Kubernetes that we're not touching again, so we're skipping a lot of stuff here. You can see the command that was running, right? You can even see that there's an IP address here. Again, that's the IP address of the pod. So any containers, all the containers would share that same IP address. And I'm going to copy this node, because we're going to look at this from the node's perspective next, I believe. Yep. So that's basically looking at it from a pod's perspective. Describe node. Yeah, so this unfortunately is a little busy, but there's lots of information about the node. We're not going to go through all that. There's one little section that's important, but it's kind of hard to read here because it's wrapping. But I'm going to try anyway, because otherwise it'll be too small. So what you're seeing here is each of these rows here is describing a different pod. Hello, there's our hello. Fluent bit is here, which is something else. GKA metrics is something else. GKA proxy, metric server, whatever this thing is, stack driver metadata agent. So the only pod that we ran was hello. That's this one. These other ones are system level pods that help in the operation of Kubernetes that came along when we installed GKE. Some of these are actually specific to Kubernetes, and some are specific to GKE's implementation. Either way, you can ignore them. Those are Google's responsibility, right? And so this is the only thing that we're running. And one clue here, by the way, there's a whole section on this, but namespaces are how you sort of, by its name, namespace is basically how you group together different pods that share the same basically root, like like a folder. In this case, default is where ours run in. You can notice that all the rest of these run in this something called kube system, which by its name suggests it's a system workload. So important one here is default. And the only other thing to observe here, and it's hard to see, but a big part of Kubernetes has to do with deciding which node to put pods on. And a lot of that has to do with how much memory and how much CPU is available on that node, and how much CPU and memory does that pod, the sum of all its containers require. And right now we have not used that feature, but that's an important feature having to do with like assigning resource requirements to your containers, which then lets Kubernetes appropriately schedule your pod to the most available node. So that's another whole whack of stuff. So that's kind of way beyond the scope of this. But so right now we have a pod running, and we can delete it by just typing in kube control delete pod hello. And that'll take a second. It's got to like inform the container that it should shut down. It should shut down. This will take like another 3 or 4 seconds. So that's really all there is in this video. And that's it. Thank you.